ARM9 is an ARM architecture 32-bit RISC CPU family. Overview: with this design generation, ARM moved from a von Neumann architecture to a Harvard architecture with separate instruction and data buses, significantly increasing its potential speed. Most silicon chips integrating these cores will package them as modified Harvard architecture chips, combining the two address buses on the other side of separated CPU caches and tightly coupled memories. There are two subfamilies, implementing different ARM architecture versions. Differences from ARM7 cores: key improvements over ARM7 cores, enabled by spending more transistors, include decreased heat production and lower overheating risk. Clock frequency improvements. Shifting from a 3-stage pipeline to a 5-stage one lets the clock speed be approximately doubled, on the same silicon fabrication process. Cycle count improvements. Many unmodified ARM7 binaries were measured as taking about 30% fewer cycles to execute on ARM9 cores. Key improvements include faster loads and stores. Many instructions now cost just one cycle. This is helped by both the modified Harvard architecture and the new pipeline stages. Exposing pipeline interlocks, enabling compiler optimizations to reduce blockage between stages. Additionally, some ARM9 cores incorporate enhanced DSP instructions, such as a multiply accumulate, to support more efficient implementations of digital signal processing algorithms. Switching to a Harvard architecture entailed a non-unified cache, so that instruction fetches do not evict data. ARM9 cores have separate data and address bus signals, which chip designers use in various ways. In most cases they connect at least part of the address space in von Neumann style, used for both instructions and data, usually to an AHB interconnect connecting to a DRAM interface and an external bus interface usable with NOR flash memory. Such hybrids are no longer pure Harvard architecture processors. Cores: ARM9 TDMI. ARM9 TDMI is a successor to the popular ARM7 TDMI core, and is also based on the ARMv40 architecture. Cores based on it support both 32-bit ARM and 16-bit thumb instruction sets and include ARM920T with 16 KB each of ID cache and an MMU, ARM922T with 8 KB each of ID cache and an MMU, ARM940T with cache and a memory protection unit, ARM9E, ARM9E, and its ARM9EJ sibling, implement the basic ARM9 TDMI pipeline, but add support for the ARMv5TE architecture, which includes some DSPS construction set extensions. In addition, the multiplier unit width has been doubled, halving the time required for most multiplication operations. They support 32-bit, 16-bit, and sometimes 8-bit instruction sets. ARM926EJS with ARM Giselle technology, which enables the direct execution of 8-bit Java bytecode in hardware, and an MMU, ARM946, ARM966, ARM968, chips. Atmel 1891 SAM9, 1891 CAP9, CSR Quattro 4300, Cypress Semiconductor EZ USB FX3, G Nova Scotia, 9215, Nova Scotia, 9210, Nintendo NTR CPU, TWL CPU, same as the DS but clocked at 132 MHz instead of 66 MHz, NXP Semiconductors LPC 3200, LPC 3100, LPC 2900, LH7A, Freescale Semiconductor I. MX1X and I. MX2X, Marvel Kirkwood, Qualcomm Atheros Arkansas, 6400, Samsung S3C24XX, ST Microelectronics Street 9 Series, Nomadic, Texas Instruments OMAP1, Texas Instruments Satara AM1X, via Wonder Media 8505 and 8650 MediaTek Mount 6516, Montana, 6573, Zilog Encore. 32. Products, documentation. The amount of documentation for all ARM chips is daunting, especially for newcomers. The documentation for microcontrollers from past decades would easily be inclusive in a single document, but as chips have evolved, so has the documentation grown. The total documentation is especially hard to grasp for all ARM chips since it consists of documents from the IC manufacturer and documents from CPU core vendor. A typical top-down documentation tree is high-level marketing slides, data sheet for the exact physical chip, a detailed reference manual that describes common peripherals and other aspects of physical chips within the same series, reference manual for the exact ARM core processor within the chip, reference manual for the ARM architecture of the core, which includes detailed description of all instruction sets. Documentation tree, IC manufacturer marketing slides. IC manufacturer data sheets. IC manufacturer reference manuals. ARM core reference manuals. ARM architecture reference manuals. IC manufacturer has additional documents, including evaluation board user manuals, application notes, getting started with development software, software library documents, errata, and more. See also: ARM architecture, list of ARM microprocessor cores, microcontroller, list of common microcontrollers, embedded system, single board microcontroller, interrupt handler, list of real-time operating systems, JTAG, references. External links: ARM Holdings, official website, quick reference cards, instructions, thumb, ARM and thumb 2, vector floating point, opcodes, thumb, ARM, GNU Assembler Directives 5. Urikov, Dennis, An Introduction to Reverse Engineering for Beginners including ARM Assembly. Online book, http://urikov.com/re for beginners NPDF.